MET 3531 Differential Equations 2 Lesson 2 Part 1 Higher Order Ordinary Differential Equations. So then when we consider the differential equation, that is the differential form of the differential equation, that is d squared y over dx square plus a1 plus a naught 0 y equals 0. So then if the differential equation is given in the differential form, we can write this differential equation in as a characteristic equation. So we called another name, that's algebraic equation or auxiliary equation. All are same. So then here we can write so we can take d squared y over dx square as lambda square and dy by dx equals lambda to the power 1, and as well as the a here lambda naught equals y. Lambda naught means actually that is 1, so that is a naught there, right? So we can write since lambda naught equals a naught, then we can write the characteristics equation as this way: lambda square plus a1 lambda plus a naught equals 0. This is the characteristic equation, where that these are the right. So we will consider some examples. So here it is given d squared y over dx square minus dy by dx minus 2y equals 0. So we can write the characteristics equation. So here d by, that is lambda square minus here lambda minus 2 equals 0. That is the characteristic equation. For this one also we can write characteristic equation. So here dy by dx square, that is lambda square 7 times this is lambda equals 0. This is the way of writing the characteristic equations. And next, so we have to write the general solution for the characteristic equation. So here we take lambda, then we can take lambda 1 and lambda 2. So then after solving this equation, we can find the general solution. The general solution obtained from the roots. There are 3 cases actually. So the case 1 is here lambda 1 and lambda 2 we taken. So case 1 is lambda 1 and lambda 2 both real and distinct, right? So they are both real and distinct. We can write the linearly independent solution are e to the power lambda 1x and e to the power lambda 2x. Then the general solution we can write y equals c1 times e to the power lambda 1x plus c2 times e to the power lambda 2x, where these c1 and c2 are the arbitrary constants. There is another special case. If the lambda 2 is equals to the minus lambda 1, then the solution we can write in this way: y equals k1 cos lambda x plus k2 times sin lambda 1x. So this is a special case. The general form is this one: y equals c1 times e to the power lambda 1x plus c2 times e to the power lambda 2x. So where c1 and c2 are arbitrary constants. So if sometimes that initial problems, the initial conditions are given, so then we can determine the value of C1 and C2, then we can write the answer. So the example here, it is given the y2 prime plus 10 times y prime plus 21 y equals 0. So first step is, so we have to write the characteristic equation. So here we can write lambda square plus 10 lambda plus 21 equals 0. Now we can find the factors here, lambda, then 3, 7, then plus and plus. So we can find the solution for this. We can take lambda equals minus 3 and minus 7. So according to this form, we can write the general solution y equals so the general form is, we know that the general form, what is it, that y equals c1 times e to the power lambda 1x plus c2 times e to the power lambda 2x, where the c1 and c2 are the arbitrary constants. So then here we can write the general solution y equals c1 times lambda 1 is minus 3x plus c2 times e to the power, then lambda 2 is minus 7x. So where c1 and c2 are arbitrary constants. So the second example is y double dot minus 5y is equals 0. So we can write the characteristic equation. As the first step. So here lambda square minus 5 equals 0. So we can write lambda square minus root 5 square equals 0. Then you can write lambda plus root 5 lambda minus root 5 equals 0. Then the answers, you can take lambda equals minus root 5 and lambda equals plus root 5. So that then the general solution, so you can write the general solution according to this form, y equals c1 times e lambda 1 is equals minus root 5 times x plus c2 times e root 5x, where c1 and c2 are arbitrary constants. This is the way of solving the differential equation with the form which lambda 1 are both real and distinct answers. So the next one, case 2 is lambda 1 is equals a1 plus ib, a complex number. If the answer is a complex number, then the general complex solution, if it is in the complex form, we can write y equals d1 e a plus ibx plus d2 times a minus ibx. And we generally, so we knew that, so we can write if it is e I theta, you know that we can write cos theta plus I sin theta. So by using this one, so we can take this one, so then which is algebraically equivalent, y equals c1 a to the power ax plus cos bx times c2 a to the power ax sin bx. that is, if you substitute here, you can take this equation. So we'll consider an example. Y double dash minus 3y dash plus 4y is equals to 0. So we can write first the characteristic equation. Here lambda square minus 3 lambda plus 4 equals 0. Then we can find the factors of this one. Here lambda minus 1, lambda minus 4, sorry, lambda minus 4, lambda, sorry, this is not have, we can't find the in this way we can find the factors, so we can use the lambda equals minus b means minus plus 3 plus or minus b square, b is minus 3, then 9 minus 4, a equal 1, b equals plus 4 over 2, a means 2. Then lambda you can write 3 plus or minus square root, here 9 minus 16, then we can find that is minus 7 over 2. So minus 1 is equals I square, so we can write 7i square over 2. Then we can find the solutions for the lambda equals 3 plus 3 over 2 plus or minus I times root 7 over 2. Then this is the form equal of lambda a plus or minus ib, right? With that form we can write the answer here. If it is in that form, we can write the general solution y. Now we can write the general solution y equals c1 e to the power ax. A equals now 3 over 2, a equals this part 3 over 2x ax times cos bx. B equals now root 7 over 2, this is this times x, right? Root 7 over 2 plus, then plus c2 times e to the power ax. A equals again e to the power, a equals this one 3 over 2 x, then sin bx. B equals this one root 7 over 2x. This is the general solution where c1 and c2 are arbitrary constants. This is the equation. Right, then third type, that's case 3, lambda equals lambda 2. If the lambda equals lambda 2, we can write the two linearly independent solution na e to the power lambda 1x and x times e to the power lambda 1x. Then the general solution is we can write y equals c1 e to the power lambda 1x plus c2 x times e to the power lambda 1x. So there's another things you have to remember. The above solutions are not valid if the differential equation is not linear or does not have the constant coefficients. Consider for example the equation y double dash subtraction x square. If x square is there, that is a not linear equation, so we can't apply this one. Equals 0. The roots of the characteristic equation lambda 1 equals x and lambda 2 equals minus x. Then roots of this characteristic equation you can take x and minus x there, but the solutions you can't write in this way, right? Before writing this way, you have to consider this is a linear equation, so equation or not. If that is not linear equation, so you can't use this way to write the answers, right? We consider an example. So d squared y over dx square minus 8 times dy over dx plus 16y equals 0. So first we have to write the characteristic equation. So lambda square minus 8 lambda plus 16 equals 0. So here you can write lambda minus 4 to the power 2 equals 0. Then you can find the two answers, lambda equals 4 and 4. So the general solution, then we can write the general solution. So we have to use this one, y equals c1 lambda x c2, then this is the general form, y equals c1 e lambda x plus c2 x e lambda x. So by considering this one, we can write the general solution, y equals c1 e lambda means here 4x plus c2 x times e 4x. This is the answer, where c1 and c2 are arbitrary constants. This is only the three conditions cases I am going to consider in this video, and actually this is a part of the second lesson, and here there are some not initial conditions or any other information given to find the c1 and c2. If it is given, you can find c1 and c2. So we will consider next as a problem, that's initial value problem. Then you can understand how we can find c1 and c2 if it is given, right? So that is all about that this lesson. Anyhow, I am going to explain another example, right? Solve the initial value problem. It is given y double dash plus 5 dash plus 6y is equal to 0, where the initial condition is given y 0 is equals to 2 and y dash 0 is equals to 3. So we will solve this. The first step is as previous, that is characteristic equation. Then we can write characteristic equation that is in this way, that's lambda square plus 5 lambda plus 6 equals 0. Then here we can see there are factors, so we can find here lambda 2 3 plus and plus. So we can take the answers as minus 2 and minus 3. So then we can write the general solution. Then the general solution, that is y equals c1 times e to the power minus 2x plus c2 times e to the power minus 3x, where c1 and c2 are arbitrary constants. Right, now we can find this c1 and c2 because some initial conditions are given there. So y0 is given, it means we can substitute, actually we can write this as yx, then it is easy, right? Then we can write this as yx. When x equals 0, we can write y0 equals c1 e to the power 0 plus c2 times e to the power again 0. Then y0 is given, that is 2 equals c1 plus c2. This is the first equation. and then y prime is also prime, that is it means we here y x is given, so we need to differentiate this one. So then here y dash x we can find, if we differentiate this one, c1 is there, then minus 2 is come here, minus 2 c1 times e to the power minus 2x, and if we differentiate that part, it is come minus 3 times c2 e to the power minus 3x. Then here when x equals 0, we can write y dash 0 equals minus 2 c1, this part is 0, sorry, this part is 1, if it is e to the power 0, that means 1, then minus c 2 times again this part is 1, then this equation we can take, and that is given as 3 equals 2c1 minus 3c2. This is second equation. So then we can solve these two equations and find c1 and c2. Here what we can do, first equation multiplied by 2, then plus to the add to the third equation. So here if we add multiplied by 2, what happened here, 4 plus 3, that is 7 equals here 2c1, then it is cancelled, here 2c2, then here come minus c2, then c2 is equals minus 7. Then by 1 we can find c1 equals, here c2 is minus 7, then plus c1 is equals 9. Now we can write, therefore, then again we can write the general solution. Now we found the values of c1 and c2, then y equals, c1 means 9 e to the power minus 2x plus c2 is minus 7, so we have to write minus 7 times e to the power minus 3x. So this is the answer if the question is given like this way. I think now you understood this. So you have to do a small assignment belongs to this things. Actually there are how to write the general solutions in these three cases. So you have to answer this, I think. So if you have any problem, you can contact me, right? Thank you.